So let me show you on the sum bit from the adder how we would do that, because I think it's useful to know. So in this case, let's suppose that we're going to split the sum bit up into two cases. The first one where x1 is false, and the second one where x1 is true. So the first half of the table has x1 false, and the second half has x1 is true. Right? And then I can look, if I ignore the first column and then just look at y1 and c0, that looks like a regular two-input truth table. Right? And my output looks like exclusive OR. Right? So I could say that in the case where I have x1 is false, my output looks like y1 exclusive ORed with c0. In the bottom case, it looks the same. It looks like a truth table for y1 and c0. And this looks like
exclusive NOR.
It looks like the NOT of the exclusive OR, right? So I'm going to put y1 exclusive OR c0 and then negate that. And then in order to create this function, I would just OR these two items together. Why does that work? Why doesn't this function mess up that one?
Because it's an OR.
Well, this is an OR. So you might think that the ones from here could combine from the ones from here and put some ones in the middle. The reason why it doesn't is because it's ANDed with x1 is false. So these things only affect S whenever x1 is false. And this term only affects S when x1 is true. So this one exactly corresponds to the top part of the table, and this one exactly corresponds to the bottom part. And that's why I can OR them together and not worry about whether any ones from this function are going to mess up this, because I know that this will be all zeros in the top half. You can verify that for yourself at home if you're not sure exactly what I was just talking about. So you can go home and figure out how does this work. Okay? But it works in a similar way that we did the min terms, right? A min term was only true in exactly one row of the column, right? Well, x1 is false for all four of these rows, and it's not false any other time. So this function here has all zeros in the bottom part, so I can OR it with something else and let the bottom part have a function of its own. Okay, so that was a trick that is absolutely not necessary for you to know, but you'll probably use it later if you do any circuits at all.
So if you were basing it on rather than x, if you were basing it on y, would you get 4 of those and vice versa?
Yes. Or if I wanted to base it on y, I would probably rewrite the truth table so that the y would be on the left,
right.
So I could just use not y and y in two separate functions.
So it's sort of like factoring it out?
Yeah, it's like factoring out the x. That's what I did. I looked at just half at a time and was ignoring the x. And I knew that in the first half of the table, x1 is false, and in the second half, x1 is true. That's exactly right. We were factoring out the x1.